26 is a combined mixture of gases problem that is easier to solve if you think about it with a picture first. So what we have is we have some kind of a container that is 4 liters and is under a pressure of 6 atmospheres. There must be some kind of a connector to another flask, which is only 3 liters, and this is under a pressure of 3 atmospheres. Now, then the connection between them is opened and the gases get to move back and forth. They will move back and forth freely, but the first thing that's going to happen is that these, which are under greater pressure, will move to this side. So everything is going to be equaled out. Gases from both sides mixed together, pressure the same in the entire apparatus. So this connector we get to ignore. It's such a tiny amount that we cannot care about it. So what we have is we have a volume, when it's all together, of 7 liters. And we need to find out what's the pressure of each gas. So we were told that this one is helium and this one is nitrogen. All right? They will not react with each other. Helium's a noble gas. So all they're going to do is mix together. And we can tell that this is really a combination of 2 Boyle's law problems. The pressure and the volume of this one before things are opened up. Whoops, cat attack. And the pressure and the volume of this one are all going to have the new volume, so they'll get their new pressures. So we do them piece by piece and then we add them together. So to start with, here's the pressure of the helium. All right, after the mixing. Helium. P1V1 equals P2V2, or P1V1 divided by, V2 will equal P2. Well, we happen to know that P1 for helium is 6 atmospheres. Volume 1 for helium is 4 liters, and the final volume is 7 liters. So that means that after everything gets all equaled out, the pressure of the helium in this combined container will be reduced down to 3.43 atmospheres. For nitrogen, we do the same thing. P1V1 equals P2V2, or P1V1 over V2 equals P2, which means that 3 atmospheres times 3 liters divided by the new volume of 7 liters equals a new pressure of 1.29 atmospheres. Right. So here we have each of the partial pressures. That's the answer to part A. What's the partial pressures of each gas? Put a little A up there now. Part B says, also please tell me what's the total pressure. Well, that's easy because P total equals pressure of the helium plus the pressure of the nitrogen, which equals 3.43 plus 1.29, which equals 4.72 atmospheres. That's the total pressure. Again, does this make sense? Well, let's see. One had 3 atmospheres, one had 6 atmospheres. The final should be somewhere between 3 and 6, and this is. So this is so far making sense. The last thing you have to do on this one, C, is find the mole fraction of helium. And the mole fraction of helium is going to equal the pressure of helium divided by the total pressure. So to find this, I just have to take 3.43 atmospheres divided by 4.72 atmospheres to find out that the mole fraction of helium in this apparatus, after everything has been allowed to mix together, is 0.727. There are no units for mole fraction, so all you have to do is watch your significant digits.